Okay, our test is going to be on Wednesday of this week. All your formulas will be on the board. We have one more formula today. All right, and we are going to do infinite geometric series. Formula is real easy to use. All right, so let's take this geometric series, and let's find from 1 to infinity of 4 times, I don't know, 1/3 raised to the k minus 1. Okay? An infinite series. Our formula, S. Now it's not S sub n or S sub anything. It's just S. Right? Is equal to T1. We know that's our first term, right? Over 1 minus R. So it's a real simple formula to use. Okay. Well, first of all, we have to find the first term. In order to find the first term in this particular series, I'm going to put in 1 for k. 1 minus 1 is 0. 1/3 to the 0 power is 1. 4 times 1 is 4. My first term is 4. If we don't know what the ratio is, we find the second term by putting in 2 for 1, or 2 for k, and then find that term divided by 4. Take a look at this formula, though. What is the ratio? 1/3. The ratio is 1/3. It's your multiplier. So, plug it into the formula. It is. You have a question, Ian?
No, it's good.
All right. 4 over 1 minus 1/3. So, if I add up all those numbers, what I'm going to get, you'd think it'd be a big number. But it's 4 divided by, and in parentheses, 1 minus 1/3. I think I'll just 4 divided by 2/3, right? 6. So the sum of the infinite series is 6. And I'll tell you why. If we were to graph something like that, that's an exponential equation, isn't it? And we know what an exponential curve looks like. Here's the parent function. Graphing the one I have for the sum, it's going to be like this. And what it's going to do, there's 6. Okay, it's going to converge, it's called. But it's going to get closer and closer and closer to 6. And when you add this infinite series, it's going to be close enough to 6 that we could call it 6. Okay? So the infinite series would be 6. Isn't that easy? There's only one hitch. Mike, can you tell me what the first term would be?
First term would be 3.
Can you tell me what the second term might be?
Would be 6.
Third term would be 12. I don't think that converges. It's called that diverges. In other words, how could I possibly add up all these numbers to infinity? I can't do it. Okay? So in this particular case, this problem does not exist. And the reason why is our multiplier, our ratio, has to be between -1 and 1. So our common ratio has to be between -1 and 1, our multiplier. Otherwise, the infinite series does not exist. Does that make sense? Kind of. All right. So, our homework. 732 to 733. 8 through 38 even? And 61 and 63. And that's your homework.